Question 1. Part A. Calculate each of the following. Part 1. 7,000 divided by 10. If I'm dividing by a power of 10, these digits are going to move one place to the right for 10, two places to the right for 100, etc. So this is going to become 700. Part 2, 65 times 1,000. So if I'm multiplying by powers of 10, the digits move to the left, the appropriate numbers of places. So this is going to become 65,000. Part 3, 9 subtract 14. So we're taking 14 away from 9. 9 is a smaller number, so we're going to go past 0 into the negatives. Okay, so 9 subtract 14 is negative 5. Part B, complete this sum. Something, add 121 equals 200. So if I do 200 subtract 121, it will tell me that missing value. So it should be 79. Part C, complete each statement with a number from the box. So we need to use the numbers in this box here. Part 1, this number is a prime number. So a prime number can only be divided by 1 and itself because it only has two factors, 1 and itself. So any of these that are multiples of 2, so 6, 8, 10, 24, cannot be prime numbers. We've also got to think about any potential easy spots for multiples of 5, so 15 and 55. So we're choosing between 13 and 49. 49 is in the 7 times tables. 49 is a square number, 7 times 7. So the prime number must be 13. Part 2. This number is a multiple of 12. So anything smaller than 12 is not going to count in this instance because we want it to be a multiple. So that's 12 and then multiples of 12 beyond that. So it gets bigger. 13 is not a multiple of 12. 15 is not a multiple of 12. But if we think about our 12 times tables, 24 is the second multiple of 12. So multiple is your times tables. And then part 3, this number is a square number. We mentioned that here. 49 is a square number. It's 7 times 7. Part D. Write 0.4 as a fraction in its simplest form. So currently we're a decimal. To write 0.4 as a fraction, I'm going to write it as 4 over 10 initially. We have one decimal place. It's in the tenths column, so that's 4 tenths. Now we need to make sure it's in our simplest form. Well, I can divide the numerator and the denominator by 2, so that becomes 2 fifths in its simplest form. Question 2a, part 1. Circle the best expression for the chance that it will snow in the UK in July. So we're looking at snow in July. Okay, we know that it can snow. So it's not impossible, but it's very unlikely it's going to snow in July because that's one of our summer months. So it would be unlikely, but not impossible because weather's unpredictable. Part 2. A dish contains equal numbers of green grapes and black grapes. Pedro takes one grape at random from the dish. Circle the best expression for the chance that Pedro takes a green grape. So there's equal numbers of green and equal numbers of black. So that's important. If there's an equal number of each, then there must be an even chance of picking out that a black or a green grape. Part B. One letter is chosen at random from the 9-letter word Australia. On the probability scale below, mark with an arrow the probability that the letter chosen from the word Australia is T. So first of all, there's a 9-letter word. So if we were writing it as a fraction, it would be out of 9. And then how many T's are there? Well, there's only one T, so it's 1/9. So let's have a look at this probability scale. We go from 0 to 1. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 equidistant spaces. 9 equally spaced lines, so each one of them must be equal to 1/9. So we'd have 1/9, 2/9, 3/9, 4/9. This is 1/9, so we're going to pop our arrow on that first line. Part 2. A, E, I, O, U are vowels. On the probability scale below, mark with an arrow the probability that the letter chosen from the word Australia is a vowel. So let's see how many vowels we've got. 1, 2, 3, 4, 5. So 5 out of 9 letters are vowels. Remember, each of these is 1/9. So 1, 2, 3, 4, 5. We're marking our arrow there. Question 3. The diagram is drawn on a 1 centimetre square grid. It shows the location of some places in a town. Part A. Write down the coordinates of the shop. So this is the shop here, and our coordinates, we deal with the x coordinate first, then we deal with the y coordinate. So if we read down from where the shop is plotted, the x coordinate is -5. And then if we read across in a straight line, the y coordinate is 3. There is a bus stop, B, halfway between the cafe and the pool. Mark the position of the bus stop on the diagram. So we're going between the cafe and the pool. And we're looking for that halfway point. So we're looking for the midpoint. Let's look at the horizontal distance. 1, 2, 3, 4, 5, 6 horizontally. And then 1, 2 vertically. So the midpoint will be half of that distance. So it will be 3 horizontally and 1 vertically. So this is our midpoint, B, the bus stop. Part C. The scale of the diagram is 1 centimetre represents 50 metres. There is a straight path from the school to the pool. How long is the actual path? Give your answer in metres. So we're going from the school to the pool. Okay, this is a 1 centimetre grid, so we can count the distance from the school to the pool. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's 8 centimetres on the diagram from the school to the pool. Every 1 centimetre represents 50 metres. So if 1 centimetre represents 50 metres and we've got 8 centimetres, we need to multiply 50 by 8. 5 times 8 is 40, 50 times 8 is 400. So the actual path is 400 metres in real life. Question 4a. Joni is choosing what to wear. She chooses from the following options. So there's 2 pairs of trousers, a black pair and a grey pair. And then there's 2 tops to choose from, white and red. And then there's 2 pairs of trainers to choose from, pink and yellow. Part 1 asks us to complete the table to show all the different choices that Joni has. The first 2 will be completed for you. So it could be black trousers, white top, pink trainers, black trousers, white top, yellow trainers. Okay, so I'm going to carry on with the black trousers, but this time we're going to choose a red top and pink trainers, and then black top, black trousers, red top and yellow trainers. So we've done both top options for black trousers and both trainer options for black trousers. So now we're going to deal with grey trousers. So we could have grey trousers with a white top and pink trainers, and we could have grey trousers with a white top and yellow trainers. Then we could also have grey trousers with a red top and pink trainers, and grey trousers with a red top and yellow trainers. Part 2. Joni is equally likely to choose any of the possible options. What is the probability that she chooses grey trousers, a red top and yellow trainers? So grey trousers, red top, yellow trainers is one option out of 1, 2, 3, 4, 5, 6, 7, 8. So the probability is 1/8. Part B. Joni jogs to the park. She leaves home at 09:43 and arrives at the park at 10:18. How many minutes does it take Joni to jog to the park? So we've gone from 9 o'clock to 10 o'clock. So between 9:43 and 10 a.m. is 17 minutes because a whole hour is 60 minutes. And then we've got another 18 minutes past 10. So we're going to add these together. So it took Joni 35 minutes to jog to the park. Part 2. Joni then walks 1.2 kilometres to her friend's house. This takes 15 minutes. What is Joni's average walking speed? Give your answer in kilometres per hour. So we have distance and time. So the distance is 1.2 kilometre. The time is 15 minutes. So we want her average walking speed, but we want it in kilometres per hour. So we need this time to be in hours. So we're going to make it into a decimal. So 15 minutes is a quarter of an hour, and a quarter as a decimal is 0.25. And then we need to remember speed, distance, time. We're working out the speed, so we're going to do the distance divided by the time. So 1.2 kilometres divided by 0.25. So we're going to multiply those both by 100 to make our lives easier. So we're doing 120 divided by 25. 25, 50, 75, 100, 125. So we've got 1, 2, 3, 4 25s to get to 100 with a remainder of 20 over 25, which is 4 4/5, which is 4.8 kilometres per hour. Part 3. Joni travels home by taxi. She's charged £2 per kilometre and she pays a total of £10, which includes a £1 tip. How many kilometres is Joni's house from her friend's house? So she paid £2 per kilometre, but we've also got a £1 tip in there. So the first thing I'm going to do is take away that £1 tip. So the distance travelled cost Joni £9. So we're going to divide that £9 by 2 to get 4.5 kilometres travelled. 5a, write down a decimal that is between 61% and 62%. So 61% as a decimal is 0.61 and 62% as a decimal is 0.62. Now what we need to remember is that actually decimal places can continue further past those two decimal places we see here. So we could have any number from 0.611, 0.612, etc. all the way up to 0.619 and then 0.62. So I'm just going to put 0.611 is between 0.61 and 0.62. Part B. Leah takes 2 science tests. In the first test, she scores 18 out of 25. In the second test, she scores 14 out of 20. In which of these tests does Leah have the better result? First test or second test, and you've got to show how you decide. So I'm going to convert these two fractions to have a common denominator, because if they have a common denominator, I can compare the numerators and decide which one is the highest value, and the higher score for Leah is the better result. So I'm going to make them both out of 100. So to go from 20 to 100, I need to multiply by 5. So I need to do the same on the top. 14 multiplied by 5. 5 times 4 is 20. 5 times 1 is 5, plus the 2 is 70. So 14 out of 20 is equal to 70 out of 100. To go from 25 to 100, we need to times by 4. So 18 times by 4, 4 times 8 is 32, 4 times 1 is 4, add the 3 is 7. So that's 72 out of 100. So now that we have a common denominator, we can compare those numerators. 18 out of 25 gives us a numerator of 72 over 100, which is bigger than 70 over 100. That was the first test. So the first test is the one that Leah had a better result in. 6a. A small tub contains n nails. A large tub contains 3 times as many nails as a small tub. So if this small tub contains n, this contains 3n, 3 times as many. Find an expression for the total number of nails in 2 small tubs and 1 large tub. Simplify your answer. So if we've got 2 small tubs, it's n plus n, and then 1 large tub is 3n, which simplifies to 5n for the total number of nails. Each nail weighs 4.5 grams. How much do 200 nails weigh? Give your answer in kilograms. So we're going to do 200 times by 4.5. Well, 100 times by 4.5 is 450. We want 200, so if we multiply this by 2, that gives us 900 grams. It wants our answer in kilograms. 1 kilogram is 1,000 grams, so 900 grams must be 0.9 kilograms. 7a. On the 1 centimetre square grid below, draw a rectangle that has an area of 16 centimetres squared and a perimeter of 20 centimetres squared. So area of a rectangle, we do length times width. And then perimeter, we do 2 lots of the width, add 2 lots of the length. So let's deal with potential numbers that would give us an area of 16. So we're looking for factor pairs here. So pairs of numbers that will give us 16 as an answer when they're multiplied together. So 1 and 16, 2 and 8, and we would have 4 and 4. Now we need to see which one of those options will work to find a perimeter of 20. So if we have 2 lots of 1 and 2 lots of 16, when we add those together, we're going to get a number larger than 20. So that can't be our option. Let's go here. 2 lots of 2, 2 lots of 8, 16 plus 4, that gives us 20. So this could be an option. Let's just double check. And then if we have 2 lots of 4 and 2 lots of 4, 8 plus 8 is 16. So that can't be an option. So we need a rectangle that has a length of 8 and a width of 2. Centimetre grid. So a width of 2 would be 2 squares and a length of 8. 1, 2, 3, 4, 5, 6, 7, 8 would be 8 squares. And what I would do, just to be safe, is 2 centimetres, 8 centimetres. You could draw this of a different rotation, so you could draw it with 2 on the bottom and 8 up as a length. That's absolutely fine. It's just that those numbers need to be 2 and 8 to meet the criteria of area and perimeter. Okay, part B. The radius of a circle is 8 centimetres. Write down the diameter of the circle. Well, the diameter is 2 times the radius. So the diameter will be 8 times 2, which must be 16 centimetres. Part 2. Write the ratio of the length of the radius to the length of the diameter. Give the ratio in its simplest form. So it wants radius to diameter. The radius is 8. The diameter is 16. And then we need to simplify. 8 and 16 can both be divided by 8. So when I divide by 8, we get 1 to 2. And that's our ratio for our answer. Question 8a. Calculate 7 multiplied by 5 squared. 5 squared is 5 times 5, so we're doing 7 multiplied by 5 multiplied by 5. 5 times 5 is 25, so we're doing 7 times 25. 7 times 5 is 35. 7 times 2 is 14. Add the 3 is 17. So 175 is the answer. Part B, put one pair of brackets in each calculation to make it correct. So we have 4 multiplied by 3, subtract 1, add 6 equals 14. So if we do 4 times 3 is 12, take away 1 is 11, add 6 is 17. So this doesn't work, so we've got to figure out how we're going to do that. So I'm going to pop the brackets here, because 3 take away 1 is 2. We have to do brackets first because of order of operations. So 4 times 2 is 8, add 6 is 14. Similar here, we've got square root of 36 divided by 2, add 1. So the square root of 36 is 6. 6 divided by 2 is 3, add 1 is 4. So we need to do something different here. So we want to get 2, so I'm going to put the bracket here because the square root of 36 is 6, but we do the brackets first. 2 add 1 is 3, so we're doing 6 divided by 3, which is 2. Question 9. Walter, Anna and Maggie all work in the same factory. Part A. Walter works for 3 hours and earns £42. Calculate how much Walter is paid for each hour. So £42 for 3 hours. So that's hours, pounds. 3 hours is 42. We want 1 hour, so we're going to divide by 3. 42 divided by 3. 3, 6, 9, 12. 3 into 4 is 1, remainder 1. 3 into 12, 1, 2, 3, 4. So it's £14 an hour. Part B. 1 week, Anna works for 8 hours and earns £120. The next week, Anna works for 12 hours. How much does Anna earn for this week? So we're dealing with hours and pounds again. So if we're working 8 hours and getting £120, we want to find out what 12 hours is. So I'm going to half this, because if I half this, I get 4 hours. So half of 120 is 60. And then to go from 4 hours to 12 hours, 4 multiplied by 3 gives me 12. So 60 multiplied by 3 would give me the money earned for 12 hours work. 6 multiplied by 3 is 18. So 60 multiplied by 3 must be £180. And that's my answer. Part C. Maggie earns £18 for each hour that she works. She's given a 2% pay rise. By how much does the amount she's paid for each hour increase? So we need to find 2% of £18. So to find 1%, we're going to divide by 100, which is 0.18. So 2%, we should be able to double that, which is 0.36. So it's 36 pence, because we were dealing in pounds. So she gets paid, by how much does the amount she's paid for each hour increase? It increases by 36 pence. Question 10. The table shows some of the values of y equals 3x for the range of x values from -2 to 2. Complete the table. So y equals 3x. This is 3 multiplied by x. So 3 multiplied by 0 would be 0. But what we can notice is this is a linear function. So what we're doing is we're taking away 3 each time. So we can treat it like a sequence. 0 subtract 3 would be -3. -3 subtract 3 would be -6. So we've finished our table. Part B. On the grid, draw the graph of y equals 3x for this range of values. This range of values are the points that are marked on the x-axis here. So we're going to plot these coordinates. So when x is 2, y is 6. When x is 1, y is 3. When x is 0, y is 0. When x is -1, y is -3. And then when x is -2, y is -6. And what should happen here, guys, is because it's a linear function, when we join these points, they should join to make a straight line. Make sure you draw that line through, guys, or you're going to lose a mark. Question 11a. The cost of a games console was £342 plus 20% VAT. What was the cost of this games console including VAT? So we're going to increase this amount by 20%. So to find 10%, we're going to do 342 divided by 10, which is £42.20. We want 20%, so we're going to multiply that by 2, or on a non-calculator, we can add 2 of them together. So that's 0, 4, 8. So it's £68.40 is 20%. We need to increase this by £68.40 because we want the cost including VAT. So 342 plus £68.40. Be careful with that decimal point here, guys. This is 342 whole pounds, but we've got that 0.40 there to deal with. And we're going to add these together. So 0, 4, decimal point, 2 plus 8 is 10, 4 plus 6 is 10, plus 1 is 11, 3 plus 1 is 4. So the cost, including VAT, of the games console is £410.40. Part B. We've got this Eduqas tablet computer. Deposit is 1/4 of the price. They pay the balance then in 6 equal monthly payments. Andy bought a tablet computer from Eduqas and paid the deposit and 6 equal monthly payments of £57. How much was his deposit? Okay, so 6 equal payments of £57. So let's do 6 times £57. 6 times 7 is 42. 6 times 5 is 30. Add the 4. So £342 was the remaining balance to pay over 6 months. So if the deposit is 1/4, then £342 must be 3/4. Okay, so if we want to find out what 1/4 was, because that's what the deposit is, we can divide the 3/4 by 3 to get 1/4. So 342 divided by 3, so 3, 6, 9, 12, 15, 18. 3's into 3 is 1, 3's into 4 is 1, remainder 1, 3's into 12, 1, 2, 3, 4. So the deposit must have been £114. And then this time there's an answer line, look. So we're going to put 114 on the answer line. Question 12. David is shopping in a supermarket. Part A. David sees this information label on the shelf. So it's for flapjacks, 250 grams, our price £1, which is £4 per 100 grams. He tells the supermarket manager that this information is wrong. Explain why David is correct. Well, in this instance, the price is wrong because at the bottom here, it tells us that it's £4 for every 100 grams of flapjack. However, we've got 250 grams here, but at a price of only £1. So we're going to pop that the price is incorrect. Part B. David decides to buy some ginger biscuits. Here are his options. 50 biscuits for £1.50, 30 biscuits for 96p. David wants to buy the packet which is better value for money. Which packet of biscuits should he buy? 50 biscuits or 30 biscuits? So I'm going to start by finding out the cost per biscuit. So I'm going to do £1.50 divided by 50. But I know that £1.50 is 150p. So I'm going to do 150 divided by 50 to make my life a little bit easier. So that tells me that for this option of 50 biscuits, it's 3p per biscuit. Now here, we've got 30 biscuits for 96p. So I'm going to do 96 divided by 30. Well, 96 divided by 30, we have 30, 60, 90, 1, 2, 3. So it will be 3 point something pence per biscuit. So this is 3 pence per biscuit. This is 3 point something pence per biscuit because of that remainder of 6. So this is cheaper. So 50 biscuits in a packet is cheaper. 13A, calculate each of the following. Part 1, 12.1 subtract 1.36. So 12.1 subtract 1.36. Be careful. Make sure you're matching up the decimal point and the numbers in the correct place value columns. I'm going to pop a 0 placeholder there just to make it a little bit easier for me while I'm working things out. So if I borrow from here, 10 take away 6 is 4. I need to borrow from here, 10 take away 3 is 7. Match up the decimal point. 1 take away 1 is 0. 1 take away nothing is 1. So my answer is 10.74. Part 2, 0.6 times 0.4. So 6 times 4 is 24. That was times by 10, and that was times by 10 to make them whole numbers. So I need to divide by 10 times 10. So I need to do 24 divided by 100, which is 0.24, and that's my answer. Part 3, 7 12 subtract 1 6. When I'm subtracting fractions, I need a common denominator. So I'm going to leave this as 7 12s, but I'm going to multiply this fraction by 2. So I get 2 12s. 1 times 2 is 2. 6 times 2 is 12. Now that I have a common denominator, I can subtract the numerators. The denominator is going to stay the same. 7 subtract 2 is 5. Part B. 56 multiplied by 1.565 equals 87.64. Use this to complete the following statement. So I'm going to compare this calculation to this one. So the 56 has been times by 10 to make 560, and the 87.64 has become 87,640. So that's been multiplied by 1,000. So this has been multiplied by 10. The answer has been multiplied by 1,000. So I need to multiply by another 100 here. So this number here needs to get multiplied by 100 because 10 times 100 is 1,000, and it'll make both sides of this calculation match. So if I times this by 100, it's 156.5. Question 14. Neil makes jewellery. Last year he sold all the necklaces he made for a total of £10,800. Part A. He made necklaces for 48 weeks and sold them all for £9 each. How many necklaces did Neil make each week? You may assume he made the same number of necklaces each week. So if he charged £9 each, I'm going to see how many necklaces he made first of all. So we're going to do 10,800 divided by 9. So 9, 18, 27, 36, 45. So 9 into 10 is 1, remainder 1. 9 into 18, 1, 2. No remainder, so we can carry those zeros up to the top. So we made 1,200 necklaces. Okay, he made them for 48 weeks. So now we're going to do 1,200 divided by 48. So we've got 48, 96, 144, 192. Okay, so 48 into 120, 1, 2. And the remainder from 96 to 120 is 24. And then we're doing 48 into 240. So I'm going to add another 48 on here, which is 240. So 1, 2, 3, 4, 5. So he made 25 necklaces a week. Part B. Neil also makes rings. Last year, for 246 days, he made 1 ring each day. He sold all of these rings for £54 each. How much more did Neil receive last year from selling rings than he did from selling necklaces? So 246 days at 1 ring a day, which is 246 rings at £54 each. So 4 times 6, 18. Add those together. 4, 8, 12. So he made £13,284 on rings. We're going to compare that with the 10,800. So we're going to take 10,800 away and see how much more he made from selling rings. So 4 take away 0, 8 take away 0, 12 take away 8, 2 take away 0. So he made £2,484 more from rings than he did necklaces. Question 15. Marcy is carrying out a survey. She wants to find out how often the people in her town use the local theatre. Marcy decides to survey only the 15 people at a meeting of her local drama group. Is this a reasonable plan? And give 2 reasons to support your answer. So I'm going to say no, this isn't a reasonable plan. And the first reason being, she wants to know how often people in her town use the local theatre, but she's only asking people that are in her local drama group. And they're more likely to use the theatre because it's something that interests them as part of their drama group. So it's biased using people in the drama group. So that's the first reason why it's not a reasonable plan. The next reason is Marcy's only asking 15 people. It's a really small sample size, so that's not going to be representative of all of the people in her town. So 15 people is too small a sample. Viola is arranging some paving slabs to make a path all round a rectangular pond. Some of the slabs are grey and some are white. There are no gaps between the slabs and no gaps between the slabs and the edge of the pond. The diagram shows how she positions her first 3 slabs. So we've got the first 3 slabs here. The ratio of grey slabs to white slabs is 3:1. The pond is 2.5 metres by 3.5 metres. Each slab is a square with side 50 centimetres. A grey slab costs £5 and a white slab costs £6. How much does it cost Viola to make her path? So the first thing we're going to do, we're going to find the perimeter of the pond, because Viola's going to put these slabs all the way around the outside of her pond. So if the pond is 2.5 metres by 3.5 metres, the perimeter is 2.5 plus 2.5 plus 3.5 plus 3.5. Well, 2.5 plus 2.5 is 5. 3.5 plus 3.5 is 7. So the perimeter of the pond is 12 metres. Okay. Each slab is a square with a side of 50 centimetres. Okay. So if it's a side of 50 centimetres and we've got 2.5 by 3.5, we can do 2.5 divided by 0.5, which means there'll be 5 slabs this way, and then 3.5 divided by 0.5 tells us there'll be 7 slabs this way. So then we'd have 7 slabs, 5 slabs. But what we need to remember is this extra corner slab here isn't flush with the pond. So we're going to have 5 plus 5 plus 7 plus 7. So that's 10 plus 14. So we're going to have 24 tiles, but we're also going to have 1 for each corner in that corner spot as well. So we're going to add 4. So we've got 28 tiles in total. Now the ratio of grey to white is 3:1, and we've got 28. So 3 plus 1 is 4. 28 divided by 4 is 7. We're sharing the number of tiles into this ratio to find out how many grey and how many white. So 3 times 7 is 21. 1 times 7 is 7. So there are 21 grey tiles, 7 white tiles. Grey slabs cost £5. So if we times that by 5, 21 times 5 is £105. White slabs are £6. So 7 times 6 is 42. And then if we add those together, it's £147 in total. Question 17. The bearing of Q from P is 140 degrees. So if we've got Q and we've got P, so if we've taken the bearing of Q from P, so we're starting at P, so we draw our north line, we're going to Q. So what it's telling us here is this angle, this bearing is 140 degrees. It wants us to find the bearing of P from Q. So if we were to draw a north line here, the bearing of P from Q would be this bearing here. Now north lines are parallel, they're parallel lines, which means these two angles are co-interior. And co-interior angles add to 180. So 180 take away 140 leaves us with 40. So this must be 40 degrees. Now this whole circle, angles around a point add up to 360. That's 40. So if we subtract that from 360, we can find the bearing of P from Q. So 360 subtract 40 is 320. So the bearing of P from Q is 320 degrees. The lengths of the three sides of a triangle are in the ratio 3 to 5 to 7. What fraction of the perimeter is the longest side of this triangle? Okay, so the perimeter would be 3 plus 5 plus 7, which is 15. And the longest side is the 7. So the fraction of the perimeter would be 7 out of 15. The perimeter of this triangle is 60 centimetres. Find the length of each of the three sides of this triangle. So we're going to share into this ratio. Okay, so we're going to share into 3 to 5 to 7. In this part, we already said that they add to 15. So we're going to do 60 divided by 15. And then we're going to multiply each of these by 4. 3 times 4 is 12. 5 times 4 is 20. 7 times 4 is 28. And you can check that they add up to 60. I'm not going to simplify the ratio at this point. So if I do, I'm just going to get back to this answer. These are the actual lengths of the triangle. So we have 12 centimetres, 20 centimetres and 28 centimetres. Question 19. The nth term of a sequence is given by 2n add 9. Work out the difference between consecutive terms. So if the nth term is 2n add 9, the difference between consecutive terms must be 2. Because when we're finding the nth term of a sequence, the number that goes in front of the n is the common difference. But we can check it. So when n is 1, 2 plus 9 is 11. When n is 2, 2 times 2 is 4, plus 9 is 13. So you can see that difference of 2 there. So the difference between consecutive terms is 2, but we can also spot that from the nth term rule. Part B, solve 2n add 9 is less than 99. So we're going to solve this just like an equation, but instead of an equals sign, we've got an inequality symbol. So I'm going to subtract 9 from both sides because it's the inverse of adding 9. So 2n is less than 90. And now I'm going to divide by 2 because it's the inverse of multiplying by 2. So n is less than 45. You have to make sure you keep that symbol there and you write it in this form for full marks. Write down the number of terms of this sequence that are less than 99. Okay, so the number of terms in this sequence that are less than 99 n is less than 45, so there will be 44, because we can't have that. This is the number of terms. We can't have 45 terms because it's less than 45, so it's going to be 44. Question 20. James has been on holiday to the USA and is flying home to the UK. The price of a gift in a shop at the airport is $65. The price of the same gift online is €60 including delivery. On the day of his flight, the exchange rates were as follows. 80 pence is equal to $1, £1 is equal to 1.2 euros. Is it cheaper to buy the gift at the airport or online? So what we're going to do, we're going to convert both of these to pounds. Okay, so let's start with the dollars. So we're going to go from dollars to pounds. So pounds, dollars, so 0.8 is $1. We've got $65, so we would times by 65. So 0.8 times 65. Well, 0.8 times 10 is 8. So 8 times 6 is 48, and then we need the 5, which is going to be half of this. 0.8 times 5 is 4. So we're going to add the 4, which gets us to £52. Okay, now we're going to convert the euros to pounds. So let's just add onto this table here. So we've got £1 is 1.2 euros. So if we've got 60 euros, we need to figure out how to go from 1.2 to 60. So we're going to do 60 divided by 1.2. So 1.2 times 10 is 12, and 12 times 5 is 60. So 10 times 5 must be 50. So that's times by 50. So when we times this by 50, we get £50. £52 compared to £50. Well, it would be cheaper to buy it online at £50. Question 21. The diagram shows a quadrilateral, so we've got this four-sided shape. Use algebra to find the size of the exterior angle y. So if we can find this angle here, this angle and y both add up to 180 because it's a straight line. So we're going to form an equation for the angles inside this shape. So we've got 60 plus x plus 75 plus 85 plus x plus 70. And because it's a quadrilateral, a four-sided shape, they should all add up to 360. So we're going to simplify this. So we've got x plus x. So we have 2x, 60 plus 75 plus 85 plus 70. So that's 10, 8, 16, 23, 29. So 2x plus 290 equals 360. We're now going to solve this for x. So the inverse of adding 290 would be to subtract 290. And the inverse of multiplying by 2 would be to divide by 2. So x is equal to 35. So 35 plus 70, substituting that x value in, tells us that this angle is 105. These are on a straight line. So 180 subtract 105 is 75 degrees. So y must be 75 degrees. 22a. Use the diagram to solve the following simultaneous equations. So we've got two linear graphs that intersect here. We need to use this graph to solve these simultaneous equations. So these equations here match what the lines are labelled on the graph. So the solutions are the x and y coordinates where the two lines intersect. Now you'll see here it says give your answer correct to one decimal place. It's because we don't have an exact scale here when we try and find our values. So this is going to be our x value. From 0 to 1 is 10 spaces. So that's 1, 2, 3, 4, 5, 6, 7, 8. So x is 0.8. And then when we go across the y, from that point of intersection. You can see it's somewhere in the middle there. So 1.45, but it wants it to one decimal place. So I'm going to round that to 1.5. Part B. The diagram shows the curve y equals x squared, add 2x, subtract 8. So we've got this quadratic curve here. Part 1, write down the y-intercept of the curve. So the y-intercept is where the curve crosses the y-axis, which is here at -8. We can also identify that from the equation, that constant that we add or subtract on the end. Find the coordinates of the turning point of the curve. So the turning point is the point of symmetry, okay? So we can identify the point of symmetry, the x-coordinate, because it'd be halfway between the two roots. So halfway between -4 and 2. So 1, 2. So halfway between -4 and 2 is -1. So the x-coordinate of the turning point, I just draw that down here. This point here, this line of symmetry, the x-coordinate is -1, and I can now substitute that into the equation of the curve to find the y-coordinate that accompanies it. So x squared, so -1 squared, because we've said our x-coordinate is -1, add 2 times -1, so 2 times x, subtract 8. -1 squared is 1, 2 times -1 is -2, and then we've got subtract 8. So 1 subtract 2 is -1, subtract 8 is -9. So the turning point has a coordinate of -1, -9. So use the diagram to solve x squared, add 2x, subtract 8. So the solutions are where it crosses the x-axis. So we've got here at -4 and here at +2. Question 23. The surface area of the Earth is 5.101 times 10 to the power of 8 kilometres squared. The Earth's oceans are 70.9% of this surface area. Estimate the surface area of the Earth's oceans. Give your answer in standard form. So because we're estimating, I'm going to make these into numbers I can deal easier with. So we're going to say that surface area of Earth is 5 times 10 to the power of 8. We're rounding this 5.101 to one significant figure. And then the Earth's oceans we'll say are 70%. So 70.9 to one significant figure will be 70%. So 5 times 10 to the power of 8 is 5, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 70% would be this divided by 100 and then times by 7. So if we divide this by 100, 1, 2, 1, 2, 3, 4, 5, 6. We have 5 times 10 to the power of 6, but then we're going to multiply this by 7, which becomes 35 times 10 to the power of 6. It wants our answer in standard form. This is not in standard form because this first number needs to be between 1 and 10. So I'm going to have to divide this by 10 to make it 3.5, which means I need to increase that power by 1 because I need to multiply it by another 10 if I was going to convert it back to a normal number. Question 24. The diagram shows a fair spinner. Eve spins it twice. What is the probability that the spinner lands on red both times? So we have 1, 2, 3, 4, 5, 6, 7, 8 sections on the spinner, and the probability that it lands on red is 1, 2 out of 8. So if Eve spins it twice, the first time landing on a red is 2 out of 8 possibility, and then the second time is also 2 out of 8 possibility. Multiplying fractions, we multiply the denominators, so 2 times 2, multiply the numerators, so we have 4 over 64 as our probability. Question 25. The table shows some information about the cost per person to take a boat across a river. So adults are represented by A, children are represented by C. The Jones family of 4 adults and 1 child pay £9.50. The Patel family of 5 adults and 2 children pay £13. The Lee family has 3 adults and 2 children. How much does the Lee family pay to take the boat? You must use an algebraic method and show all of your working. So I'm going to form 2 simultaneous equations using this information here. So for the Jones family, we've got 4 adults plus 1 child, and that's £9.50. The Patel family have got 5 adults and 2 children for £13. So I'm going to solve these equations now to find the cost of an adult and a child. So I'm going to multiply this one by 2, so it becomes 8a plus 2c equals £19, and then I'm going to rewrite the Patel's equation underneath. So what I've got here are 2 equations where the c variable matches, so they're both positive here, so I'm going to subtract these equations away from each other to eliminate the c. So 8a subtract 5a is 3a, 2c subtract 2c eliminates it, 19 subtract 13 is £6. So if 3a is £6, if I divide by 3, it tells me that an adult is £2. So now that I know an adult is £2, I'm going to substitute it into one of these equations to find out what a child is. So let's use this first equation. So 4 times 2 plus c is £9.50. 8 plus c is £9.50. So c is £9.50 subtract 8, which is £1.50. So an adult is £2, a child is £1.50. So the Lee family has 3 adults. So 3 times that £2 that we've worked out. And they have 2 children, so 2 times £1.50, which is 6 plus 3. So it's going to cost them £9. So the Lee family pays £9.